All right, welcome to section 1.4, part 1. The section title is called Extrema, which you probably don't know what that is yet, and average rates of change. Okay, both of these you may not know what they are, but you will in due time. Okay, so the essential question is still the same thing that we had from last section. What types of graph-specific information are important for functions? So what kind of information can we get from graphs? Okay, there's still lots and lots of things that we can gain from a graph of a function. Okay, what are we specifically going to learn in this section? We're going to determine intervals on which functions are increasing, decreasing, or constant. And the second thing we're going to learn is how to determine maximum and minimums of functions. Okay, another word for maximums and minimums are extrema. Okay, so we're going to learn those two things. All right, so what does it mean to have an increasing or decreasing behavior? Okay, and because we always read from left to right, okay, we read our math graphs from left to right. Okay, so we want to know where this particular graph is increasing. All right, so where is it increasing? Okay, so I'm going to start on the left. So we're starting with the arrow going to the left. It's starting at negative infinity, and it's going up to what x value? It's going up to, if you notice, negative 5 is where it stops decreasing. So from negative infinity to negative 5, the graph is increasing. So it's going up. And now notice from negative 5 to what number? It is at flat or constant. Okay, constant and flat mean the same thing. So from negative 5 to 0, our graph is constant or flat. So negative 5 to 0, our graph is constant, and then starting at 0 and going down, it is decreasing. So it's going down from 0 to positive infinity. So from 0 to positive infinity, our graph is decreasing. Okay, not all graphs have increasing, constant, and decreasing. It may just have one or the other, or it may just be one. Okay, so or it could be all three like this one. But this is just an interval from negative infinity to negative 5, it's going up, so it's increasing. Negative 5 to 0, it is constant or flat, and then from 0 to positive infinity, it is decreasing. All right. So this just kind of explains that the whole thing there, what it means for something to be increasing or decreasing from left to right. Like this one, it's going up. So if I plug in x1 into my function and I get this particular y value, and then I plug in another x value in and I get this y value. If this y value is bigger than the one to the left of it, it must be increasing. Same thing here. If I plug in x1 and I get f of x1, and then I plug in x2 and I get f of x2, if this number is also bigger than the one on the right, then it's decreasing. And then lastly, if I plug in x1 and x2 and I get the same exact y value, then you know it is flat or constant. Okay, so this chart just kind of explains those ideas. All right, so example 1. It says use the graph to determine intervals in which the function is increasing, decreasing, or constant. And it doesn't have to be all. It could be 1, it could be 2, it could be all 3. So let's see what this one is. So here's our function x squared minus 4, and I've graphed it for us here at the bottom. Okay, so we want to know the interval where it is increasing or decreasing. All right, so let's start on the left. We always start on the left. All right, so here's our leftmost point. This arrow means we're starting at negative infinity. And are we going up or down? So our graph is from left to right is going down, so we are decreasing. So I'm going to go to decreasing. So from negative infinity, and where does it stop decreasing? So at this point right here, it stops going down. So that is at 0. So it's decreasing from negative infinity to 0. And then from 0, it is now going up. So it is increasing. So from 0 to the arrow means positive infinity, it is increasing. And there is no constant or flat. This one is just increasing and decreasing. All right, example 2. Now we could, let me actually go back to this example. I could graph this. I'm going to go to my y equals, and I have it right here, x squared minus 4, so the second one down. And if I go to my table, and I'm starting my table at 0, and I'm just going by halves, 0.5, and you can kind of see what's happening here. So I'm going to go back up to negative here. Now let's look at the y values. 68.25, 60, 52.25, 45. So as you notice, if my x's are negative and they're getting bigger, my y values are getting smaller. So 38.25, 32, 26. So we want to see where it stops getting smaller. 8.25, 5, 2.25, 0, negative 1 point, it's still getting smaller, negative 3, negative 3.75, negative 4. And then notice it's now getting bigger. Negative 4, it's turning into. So this point right here is where it stops decreasing and it starts increasing. So the numbers now should be getting bigger. Negative 3, negative 1.75, 0, 2. They're getting bigger now. So you can also look at the table. Tables are pretty powerful tools for us. All right, so let's look at the next one. It says the same thing. Use the graph to determine intervals in which the function is increasing, decreasing, or constant. So here's our new equation, negative x cubed plus x, and here is our graph. Okay, so let's start at the left. So I'm starting here. This is negative infinity, and I'm going down to begin with. So it's decreasing to about this point right here. All right, so let's see. So it's decreasing, and this is just an estimate. If you're looking at the graph, it's just an estimate. So negative infinity, to where does it look like this point is on the x-axis? Does it look to be about negative 1/2? So negative 1/2. And from negative 1/2 to where is it increasing? It's increasing to about here, which is at positive 1/2. It looks to be right in between 0 and 1. So it is increasing from negative 1/2 to positive 1/2. So this section right here, this black section from here to here, it is increasing. And then from 1/2, keep going, what is it doing? It's going down. So it's decreasing also from 1/2 to positive infinity. The arrow means positive infinity. And if you graph this and looked at the table, you would see that this is indeed true. And you could also prove that it's at either negative 1/2 or positive 1/2 right from the calculator, from the table. But this is a pretty good estimate. All right, so that's part one. Now, it says in the book, and I think this is pretty important, so that's why I wrote it. It says, while graphical approach to identify the intervals on which a function is increasing, decreasing, or constant can be supported numerically or by tables. So if you want to write by tables on your calculator, so numerically means by tables. It is good, you can do that. Calculus is often needed to truly confirm these numbers. So when you get to calculus and you get to college, you will be using calculators to actually prove these numbers are true. But for now, we're just going to use all the information that we have. Okay. So we also have some new words that we need to focus on. So we have this word extrema, and extrema are critical points at which a function changes its increasing or decreasing behavior. So what you need to remember for this section is extrema points are maximums or minimums. Okay, and we'll talk about that in a second. And then we have something called a point of inflection. Points of inflections are points where the graph changes its shape. It goes from bent upward to bent downward or vice versa. All right. So these are two very important things that we need to know. So let's look at a graph to kind of show these. Okay, I'm going to start over here on the right. This point right here is a maximum. It's above. It's on the top. It's the furthest up point. And notice maximum. So from left to right, we're increasing. We're going up. And then as soon as we get to the maximum, that's the point where it starts changing shape and now it goes down. So it went up and now it is going down. Okay. Now down here to the left, we have something called a minimum point. So starting at the left, we're going down. And then as soon as we get to the minimum, now we are going up. So maximums and minimums are called extrema. So this is an extrema point. Extreme meaning either high or low. And then in the middle here, we have something called a point of inflection. Okay, and notice that it was going up. So it changes its shape. So this one is bent downwards, now it's bent upwards. Or it could be vice versa. It could be bent upwards and then it changes bent downwards. So a point of inflection is where it's kind of like a parabola broken in half. Okay, so those are the two most of the important vocab terms in this section. All right, so now we're going to talk more about these maximums and minimums. All right, so there are certain types of maximums. So if we look at this graph here in this chart, notice that there are two types of maximum points. There's this one on the left and there's one on the right. The one that is the highest, so if you have multiple ones that you have to choose from, the highest one is called the absolute max. Okay, the absolute max. The one that is also a maximum, yet it's not the highest, is called a relative max. Okay, and that is this one on the left here. So that we have two maximums. The one, the shorter of the two, is called a relative. The highest one is called the absolute. The same thing is true for minimums. We have two minimum points here. The one that is the lowest is called the absolute minimum. And the one that is not the lowest, but it is a minimum, is called the relative minimum. Okay? So those are also some terms that's called classifying. So classify. If I ask you to classify, that's what I want you to do. I want you to call it either a relative or an absolute. All right, so example 3. Estimate and classify the extrema for the graph of f of x. So when we're just looking at a graph, we are really just estimating. Okay, so it wants to know the extrema. Okay, so let's do maximums first. Do we have any maximums? Okay, I see one right here. So let's estimate where that maximum is Okay, what do you think the ordered pair is? So it's left, here's 1, and here's 0. So doesn't this look to be about 1/2? So the x value is -1/2, and about how high is it? So here's 1. I don't know, that's probably about 0.25, I would say, 0.25. Okay, I think that's a good estimate. All right. And now let's estimate the minimum. Okay, let's find the minimum and estimate that. So I'm going to say minimum equals, and the minimum is down here to the right. All right. And notice that this goes off forever up and this goes off forever down. So let's figure out what this minimum is here. So it looks to be 1 to the right. And how many down? It looks to be just 1 tick mark down. So it's 1, -1. Now we have to classify. It says also to classify this. So it's either relative or absolute. Now, because this goes up forever, this maximum here cannot be called absolute because it has higher points. This point is higher than this one here. So if it goes up to a positive infinity, then this one is going to be just called a relative max. Not an absolute because it has points that are higher. The minimum, same thing. This graph goes down forever to -infinity. So this cannot be the absolute minimum. It is just a relative minimum. Okay, so we have a relative max, relative min. We do not have any absolutes because this graph goes positive infinity and it also goes to -infinity. All right. So that's how we estimate. That's only an estimation. We didn't do anything using any calculator or anything. Okay. So we're going to save this example for class. It says use your graphing calculator to estimate. Actually, not to estimate, to find and classify the extrema for the graph of fx. So if you want to try, if you remember from Algebra 2 how to find the maximums and minimums from that, find all the relative maximums, relative minimums, absolute maximums, and absolute minimums. All right, hopefully that makes some sense. We will see you tomorrow. Have a good night.